So yesterday we looked at the special angle relationships when we have a pair of parallel lines cut by a transversal. We use the special angle relationships to solve for x, and we use x to find the missing angle measures. We're going to take this one step further, and now we're going to have expressions where we have more than one variable. So if you take a look at this problem, we have three expressions and two variables, x and y. We're going to be using the special angle relationships to solve for x and y, and we're going to find the angle measures of all of the angles formed when a transversal cuts through a pair of parallel lines. So the first step you have to ask yourself is, with these three expressions, where do you see an angle relationship? I'm going to take a look at 8x minus 31 and 5y plus 35. These two expressions do not form a special angle relationship. 5y plus 35 and 6x plus 3, they form an angle relationship. They are same side or interior angles or consecutive interior angles. If we set 5y plus 35 and 6x plus 3 equal to 180, we cannot solve because we have two different variables. Our first step is we have to find expressions where the variables are the same in order to find that variable. So I'm going to take a look at 8x minus 31 and 6x plus 3. They are on the inside of the parallel lines, and they are on alternating positions. So 8x minus 31 and 6x plus 3 are alternate interior angles. What do we know about alternate interior angles? They are congruents. So I'm going to take 8x minus 31 and 6x plus 3 and set them equal to each other to find the value of x. I'm going to take 8x minus 31 is equal to 6x plus 3. I'm going to use some algebra to get x by itself. Subtract 6x on both sides. 8x minus 6x is 2x minus 31 equals 3. Add 31 on both sides, and I get 2x equals 34. Divide by 2, and I get x equals 17. Now that I know what my x is, I'm going to go back into each of these expressions where I have the x variable, and I'm going to plug them in to find what those angle measures are. So I'm going to take 8x minus 31 and 6x plus 3. All right, now that we know what x is, I'm going to substitute x into each of these expressions to find these two angle measures. So 8 times 17 minus 31. 8 times 17 is 136. Minus 31. 136 minus 31 is 105. So we found our first angle measure, 105 degrees. Now, if I did the math correctly, this angle measure should be 105 because alternate interior angles are congruent. So let's just double check. 6 times 17 plus 3. 6 times 17 is 102 plus 3. So 102 plus 3 is, look at that. Doesn't surprise me that 105, it is 105. All right, so these two angle measures are going to be 105 degrees. So with a different permanent marker, I'm just going to say that this angle measure is 105 and this angle measure is 105. It is no longer an expression because we know that these two angle measures are 105 degrees. Let's go back to this 5y plus 35 and 105 degrees. We said before that these two angles are consecutive interior. So since they are consecutive interior, that means that we're going to add both of these expressions and set them equal to 180. Recall from the last video that consecutive interior angles are supplementary, and supplementary angles add up to 180. So I'm going to take 5y plus 35, and I'm not going to add 6x plus 3. Now that I know that this is an angle measure, I'm going to add it by 105 is equal to 180. Here I have like terms, so I have 5y plus 140 equals 180. Subtract 140 on both sides, and I get that 5y is equal to 40. Divide each side by 5 to get y by itself, and I get that y is equal to 8. Y equals 8 is going to help us find what this angle measure is. So what I'm going to do is I'm going to take the expression 5y plus 35. Let's do some predictions. If we know that the sum of these two angle measures add up to 180, I can immediately find out what this angle measure is. Well, what angle measure does this angle have to be to add to 105 to equal 180? Well, 75 plus 105 equals 180. Let's double check to make sure that this angle measure is 75. So I'm going to take 5y plus 35, and I'm going to substitute y equals 8 into y. 5 times 8 plus 35. 5 times 8 is 40. And 40 plus 35 equals, look at that, I was right, 75 degrees. So this angle is 75 degrees. Let's use 105 and 75 degrees to complete all of these missing angle measures in the parallel lines cut by a transversal. Now I don't have to do any more algebra. I can just use vertical lines and linear pairs to find the rest of these angle measures. Well, this angle and this angle are vertical angles. Vertical angles are congruent. So if this angle measure is 105, this angle has to be 105 degrees as well. Using vertical angles again, if this angle measure is 75, that means this angle measure is 75 degrees as well. What is this angle measure? This angle and this angle are alternate interior angles. Alternate interior angles are congruent, so that means that this angle measure is 75 degrees as well. Again, vertical angles, that means this angle is 75 degrees as well. And this angle measure is 105 degrees as well. Let's double check our work. Here we have supplementary angles. Two lines that are on a straight line add up to 180, while 75 degrees and 105 degrees adds up to 180. Some of the expectations I have for you guys in the future is you're going to have to use the special angle relationships with more than one variable, and you have to complete all of the angle measures using your knowledge of vertical angles, supplementary angles, and linear pairs.